Hi, boys and girls. My son wants to know why I start every single recording like that. Hi, boys and girls. I don't know, just something that I'm doing. Um, and now I'm more aware of it. So today is Thursday. We're up to day 9, remote learning. Um, and I'm here again to talk about some math. We're playing a math test on Tuesday on line plots. So today's our last lesson. 11-4, again on solving problems. Our last lesson is always about problem solving. So we're going to get a little more in depth, and we're actually going to analyze other students' conclusions about line plots. So we're going to look at a line plot, we're going to see what somebody else has determined about that line plot, and then we're going to figure out if they are correct or where they may have gone wrong. So I'm going to share my screen with you right now. It was great seeing everybody yesterday, and I'm hoping maybe we can do another Zoom tomorrow, Friday morning, to talk about wonder and something else a little exciting. So I'm setting that up. Keep your eye out on that. Yeah, I really feel like I want to wrap up wonder. I don't really want to wrap up wonder, but I feel like there's some things we really need to talk about. Okay, so here I am. Oh, gotta hit share. There we go. Here I am in your math textbook workbook, page 609, and we're on 11-4, problem solving. I can use what I know about line plots to critique the reasoning of others. So critique, when you give a critique, then you're just saying what you liked, what you didn't like, what they could do better on, what they did really well. Critiques don't always have to be nasty and mean. Just critical, just honest. So in the solve and share, if you don't have your book, go run and get it. You can pause me and come back. We see that a class made a line plot showing the amount of snowfall for 10 days. Nathan analyzed the line plot and said, the difference between the greatest amount of snowfall recorded and the least amount of snowfall recorded is 3, because the first measurement has 1 dot and the last measurement has 4 dots. How do you respond to Nathan's reasoning? Just going to give you a second to think about that. See, is Nathan right? Is Nathan wrong? Give me a virtual thumbs up or a virtual thumbs down. Oh, good. I see so many of you have gotten the answer correct. So let's take a look at the line plot. Here we've got our title, which is snowfall. We've got our label down here for inches, and we have our intervals of measurement, starting with 3/4 of an inch all the way ending to 1 3/4 of an inch. And we can tell that the intervals between here is going to be 1/4 of an inch. So 3/4 plus 1/4 would give me 1 whole plus 1/4 would be 1 1/4, 1 2/4, 1 3/4 inches. So Nathan looked at this and he said, well, the difference between the greatest amount of snowfall, which is 1 3/4 inches, and the least amount of snowfall recorded, which is 3/4 of an inch, is 3. Because the first measurement has 1 dot and the last measurement has 4 dots. What do these dots represent again? Those are the amount of snowfalls. So, or I should say the amount of days that there was that amount of snowfall. So for example, when I'm looking at this right here, I see that there was 1 day that 3/4 of an inch of snow fell. There were 2 days when an inch of snow fell. There's 1 day when they had 1 1/4 inches of snow. There were 2 days when 1 2/4 of an inch of snow fell. And then there was 1, 2, 3, 4 days when 1 3/4 inches fell. So these dots really represent days or events of snowfall, right? Of snowfall. So when Nathan took these dots of 4 and subtracted that dot of 1, 4 minus 1, that's 3. That's not the difference in the measurement. That's a difference in the number of snow days, not the difference in the measurement. So the difference between the greatest amount of snowfall and the least amount of snowfall, we need to actually do the number here, would be 1 3/4 minus 3/4 which would be 1 inch. 1 inch. See if I can annotate that. See if we can do good old text. So 1 3/4 minus 3/4 is going to equal 1 inch. Okay, so that is the equation. And what can we say? Nathan was wrong in his reasoning because he found the difference in days, not inches of snow. There we go. Okay, so I don't know if I can move this down. No, doesn't look like I can. So, oh, I wonder if I can change that color. No, I guess I apparently can't get back to it. So 1 3/4 inch minus 3/4 of an inch is 1 inch. So that's the equation. We're looking for the difference between the greatest amount of snowfall recorded and the least amount of snowfall recorded. Now, if we really wanted to know the difference in the total, then we would have added those dots up together. You know, 1, 2, 3, 4, and then another 3/4 plus 3/4 plus 3/4 plus 3/4. That would have been 12/4 3. That would have been 4 minus 3/4. But they don't want to know. They want to know the difference between these two numbers here. So 1 3/4 minus 3/4, which would equal 1 inch. They didn't ask for the total amount. If they did that, then we'd have to consider all of the dots. But they were just asking about what was recorded. So 1 3/4 minus 3/4 would equal 1 inch. So Nathan was wrong in his reasoning because he found the difference in the number of days, not in inches of snow. Okay, he was subtracting the number of days that had the 4 days here that had 1 3/4 inches compared to the 1 day that only had 3/4 of an inch. Okay, sorry, Nathan. Sorry, Nathan. All right, so we're gonna clear all my drawings and let's get back to my mouse. There we go. And we're gonna go down to what question can you ask about the line plot above if Nathan's reasoning is correct? What question can you ask about the line plot above to find if Nathan's reasoning is correct? I guess we have to ask, what do these dots represent? That's the question we asked in the first place, right? What do these dots represent? And those dots represent days. They don't represent the amount of snowfall. They represent the days, the number of days that had that snowfall. And so if you question that to begin with, you know that Nathan, sorry, Nathan, you are incorrect. You are incorrect. So we can write that down. We can ask, what do the dots represent? Okie dokie. And let's see, now I know I can change that up ahead of time. There we go. All right, let's go on to the next page. Okay, so here we are on the next page here, and it's going to explain a little bit more. How can you critique reasoning of others? Again, give them feedback. Ooh, we talked about effective feedback. Be honest and give good feedback. So the line plots show the amount of rainfall for 2 months. So we'll look over at the line plots here. We've got rainfall in January in inches. And I notice 1/8, 2/8, 3/8, 4/8, 5/8. That's increasing by 1/8. That's the interval there. And then rainfall in February. And we've got 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8. Also by 1/8 intervals in inches. All right. So Val said the total rainfall for February was greater than the total rainfall for January because 7/8 plus 7/8 equals 14/8, and the highest rainfall in January was 5/8. So when I look at this, I want to see what Val said, and Val said the total rainfall. We know that the word total means putting things together. And if she wants to know the total rainfall for February, but all she put together were these two, dots here, is that total? No, that's I guess you could say the total for the greatest amount of rain that fell. But that's not the total of the rain that fell. And same with 5/8. That's just how many, I guess, days had that greatest amount of rain that fell. But that's not the total. So let me just undo that. Okay. So Val compared the two highest amounts of rainfall for each month, but that's not the total rainfall. That's not the total rainfall. So how can I critique the reasoning of others? I can ask questions for clarification, decide if the strategy used makes sense, and look for flaws in estimates or calculations. So here's Val's thinking. Val's reasoning is not correct, okay? She compared the days with the greatest amount of rainfall for the 2 months. The days with the greatest amounts of rainfall are not the total for the month, which is what we talked about. So if she really wanted to know the totals for the month, she would have to add up the total for each month and then compare those two. So that would be 5/8 plus 3/8 plus 3/8 plus 3/8 plus 1/8 plus 1/8 plus 1/8. So it would be 3 times 3 is 9, 10, 11, 12 plus 5 would be 17/8, which would be 2 1/8. And then for February, we would have 7 and 7, which is 14, and 5 is 19, 20, 21, 21/8. So 17/8 and 21/8 is going to give us a difference of 4/8, which would be 1/2. And I decided I had at first changed this to 17/8 to 2 1/8. But then when I saw we were subtracting, I said, let me just leave it as an improper fraction, and then I will. Oh, sorry, I lost me there for a second. Then I'll change it back after. So same thing. So January, 1/8 plus 1/8 plus 1/8 plus 3/8 plus 3/8 plus 3/8 plus 5/8 equals 17/8. Where did those numbers come from? The dots. Okay, so there's 3 dots. Whoops, 3 dots above 1/8, so I have to add that 3 times. There's 3 dots above 3/8, so I have to add 3/8 3 times, and 1 dot above 5/8, and that equals 17/8. And then February, same thing. Now it looks like not as much rainfall fell in February, doesn't it? They had less days, but it rained more on those fewer days that it did actually rain. So for February, we're adding 1/8 plus 1/8 plus 5/8 plus 7/8 plus 7/8, which equals 21/8. And then when you subtract those two, that gives you 4/8. Okay. Bev thought January had more rainfall because it rained on 7 days, and February only had to rain on 5 days. How do you respond to Bev's reasoning? I love when I already answer the question before I even look at it. I mean, that's just, see how you're always thinking? See how you're not just responding to the question, but I was actually thinking about those line plots. So I kind of already answered that. So she thought January had more rainfall because it had more dots. And February did not have as much rainfall because it has less dots. But again, you have to look at the question that's really being asked here. The dots represent the number of days. So if the question had been, or if Bev had reasoned that January had more rainy days than February, well, she'd be correct. Because in January, there were 3, 6, 7 days of rain. But in February, there was only 2, 4, 5 days of rain. However, more days of rain doesn't mean more rain. So just because they had more days of rain does not mean that they had more rainfall. And we can use the data right here to prove that. January, with its 7 days of rain, only had 17/8 of an inch. February, with only its 5 days of rain, actually had 21/8 of inches of rain. So sorry, Bev, but your thinking is not reasonable. So let's write. So Bev's thinking is not, we'll say reasoning, is not accurate because we have to calculate the total inches of rain, not the number of days of rain. There we go. Yeah, just rereading it to make sure it makes sense. Best reasoning is not accurate because we have to calculate the total inches of rain, not the number of days of rain. If her question had been, oh, it rained more days in January than it did in February, that would be accurate, but it's not. Okay. So if you have any questions, you can always feel free to message me about that. Let's go on to the next page, and I think we'll do some of this together. Let me just undo, whoops. All right, so now we're going to practice here. At a dog show, a judge wrote down the heights of 12 dogs. Cole made a line plot of the heights shown to the right. He concluded the height with the most dots is 1 1/4 feet, so that is the greatest height of the dogs at the dog show. What is Cole's conclusion? How did he reach this conclusion? Okay, so I'm going to, before I even answer, I want to look and kind of really study this line plot so I can understand it. So I have my title, dog heights. We've got my feet here, which is my label to tell me what these numbers mean. So 1 foot, 1 1/4 foot, 1 2/4 feet, goes all the way up to 3 feet. Okay, so I can see also my intervals are 1/4. We're counting by 1/4, right? 1 plus 1/4 would be 1 1/4 plus 1/4 is 1 2/4 plus 1/4 is 1 3/4. Okay. And I can see how the data is spread out here, dog heights. All right. And when I look at 1 1/4, I see that that is the tallest. It has the most dots. That makes it the mode. It happens most often. Most often. So when they were measuring the dogs, most of the dogs they measured were 1 1/4 heights. That was the most common. I don't know if it's accurate to say 2, 4, 5, 6, 7, 8, 9, 10, 11, 12, 1, 2, 3, 4, 5. Nah, not quite most, but anyway, most often. So he's saying, though, the height with the most dots is 1 1/4 feet. So that's the greatest height of the dog at the dog show. Well, I'm on a number line here. I know the number on the right is going to be the highest number, the greatest height in this case. 1 1/4 is all the way down here. Is that the greatest height of the dogs? No, it's just the most common. The most common. It must have been measuring. It must have had some short dog there. So they're just measuring the dogs here. This is the most common measurement. That does not mean it's the greatest. Just because it has the greatest number of dots just means that it occurred the most times. But that's not the greatest height. So, oh boy, we're really got to tell a lot of people today. They're not being really accurate. So Cole's concluded that 1 1/4 inches was the greatest height because it had the most dots. Is Cole's conclusion correct? Explain. And I think we already know, we've mentioned this already. Hello, text box. There we go. Cole's conclusion is not correct. He found the mode, not the greatest height, which is 3 feet. 3 feet. Now, had there not been any dots here, then we wouldn't have counted 3 feet. Just so happened that it is the last number on the number line that we're seeing, and there are dots above it. So yes, that is the greatest height. But if they had stopped here at 2 3/4, there was no 3, and there's no dots over 2 3/4, I'd have to go back to 2 2/4. Okay, so the greatest height includes the number that has dots over it, not just the number on the number line. All right, so questions about that? Cole concluded that 1 1/4 inches was the greatest height because it had the most dots. That's the mode. That's the mode. And his conclusion is not correct because he found the mode, not the greatest height, which is 3 feet. Okay, moving right along. And we're going to look at this line plot. And it looks like it says 4th grade attendance, number of absences in a week. Oh, that almost sounds like like an oxymoron. If you're attending, you can't be absent. Okay, so let me wrap my brain around this. 4th grade attendance, but they're really just showing the number of absences in a week. Oh my goodness. Quite a few absences here. Wonder what was going on. Number of absences in a week. So we've got our number line 0 through 8. 0 meaning that there were 0 absences. 8 meaning there were 8 absences. So number of absences in a week. If we look at 0, we've got 1, 2, 3, 4, 5. That means 5 people were not absent. 1, 2, 3. 3 people were absent one day. 2 people were absent for 2 days. 1, 2, 3, 4, 5 people were absent for 3 days. And oh my gosh, all the way out here, this guy all by itself. What do we call that? Outlander? Outlier. The outlier is 7. He's all by himself. Somebody was out for 7 days. I wonder if they were on vacation. Maybe they went to Florida. Maybe they went to Hawaii. Ooh, I think you need more days than 7 for Hawaii though. All right, so now I can see what Natasha is saying about this. Natasha keeps a log of absences in her 4th grade class. She creates this line plot that is shown here. Each dot represents the number of absences in 1 week. Natasha says the total number of absences is 16 because there are 16 dots on the number line. What is Natasha's argument? How does she support it? Okay, so I'm gonna start over here. Natasha's argument is there were 16 absences because there are 16 dots on the line plot. All right, give me those virtual thumbs up or thumbs down. Do you think she's correct? Is that right? Were there 16 absences? Well, let's count, make sure there's 16 dots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. There are indeed 16 dots. And each one of those dots represents a person who is absent. However, let's take a look at that 0. Can we include those people as being absent? If you have 0 absences, are you actually absent or are you actually there? If you have 0 absences, you're not absent. You are at school. But those other people, those other dots, if you have just 1 day that you're absent, you are absent. You were not at school that day. So we can't really count the 0 ones, can we? We can't. So there's 16 people in the class, maybe, but there were not 16 absences. So let's count the dots, not including the 0. So it would be 3, 5, 6, 7, 8, 9, 10, 11. 11. There were 11 absences. Let's see if I can fix this. Does Natasha's reasoning make sense? See if I can fix this. There we go. Natasha, I thought you were right. I thought we had somebody who's right. So Natasha is incorrect because you can count the 0 absences. Almost had us there. All right. So actually 1, 2, 3, 4, 5. So there were 11. Is that what we said? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there were only 11 absences. It's like saying 16 people didn't do their homework, right? So if I have how many people missed their homework 0 times? Well, if you didn't miss your homework, I can't count you as missing homework, right? If you miss it 0 times, I can't count that as you missing homework. So I hope that makes sense to you. that if you were absent 0 times, then I can't say that that those people were part of the absences. They're not. They're there. So again, it just cracks me up that in the beginning, I'm like, well, wait a minute, why are we doing attendance and then absences? It kind of sounds like an oxymoron. So maybe that was on purpose to see if you could read it accurately. Natasha also says there's an outlier in her data. Is she correct? All right, Natasha. Woohoo. So Natasha, let's see, is there an outlier? We already called that an outlier. So yes, there is an outlier. So Natasha is correct. Natasha is correct. 7 is the outlier because it is far away from the other data. All right, so make sure you get all that down. Hopefully you understand why Natasha's reasoning that sounded so good is off. See how they try and they step it up just a little bit. There's that critical thinking skill. It would look like, oh, 16 dots, 16 absences, but if you have 0 absences, you're not absent, you're there. So we can't count that in the big picture. Nice job, Natasha. And then there was an outlier. Good. All right, let's see what the next page has in store for us. All right, so I think I'm gonna leave you here. I will discuss this, but I want you to do these last 3 on your own. You see that they have a nice data chart here for you to kind of organize into a line plot. So let's see, Mr. Pally is building a desk using screws of different lengths. The instructions show how many screws of each length he will need to use. Mr. Pally concludes he will use more of the shortest screws than the longest screws. Draw a line plot to show the screw lengths Mr. Pally will use to build the desk. So we're going to take this data chart here and you're going to make it into a line plot. You're going to need a title. Anyone have any ideas for a title? Yep, screw lengths. There's your title right there. Anyone know what we're going to put on the line plot? Yep, we're going to put these numbers on the line plot. So I'll kind of maybe just do a little bit here for you. So if this is our number line, you might not be able to fit it all here. If this is our number line, these numbers in here will go on the number line. So if I'm looking for the smallest number, and I see right now that it's in eighths, right? So it's in eighths and it looks to me like 3/8 is the smallest. So 3/8, oops. 3/8 would start here. And we would increase, it looks like, by 1/8. So 3/8, 4/8, 5/8, 6/8, 7/8, 1 whole, 1 1/8, 1 2/8, 1 3/8, 1 4/8, 1 5/8, 1 6/8. And we've probably gone too far. So we really just have 1 4/8 as your furthest here. So if I start here at 3/8, I have to say, well, how many times does 3/8 appear? And it looks like 1, 2, 3, 4, 5, 6. So I would need to put 6 dots above 3/8. Okay, and then you continue. And then once you're finished, you can look at the question, which says that Mr. Pally concludes he will use more of the shortest screws than the longest screws. So on my line plot, I would have to compare the shortest screws, which we just said was 3/8, and the longest screws, which looks like it'd be 1 4/8, and we'd have to compare how many dots are above each one. Okay, so you'll get to finish that. And how can you use the line plot to find which length of screw Mr. Pally will need the most? Most, what are we using there? We're using the mode, most often, most often. So he wants to know how you can use the line plot to find that. So you're going to be looking for the one that has the most dots, the highest dots. And then is Mr. Pally's conclusion really reasonable? How did you decide? If not, what can you do to improve his reasoning? So you're gonna have to go back up here and look at what was his reasoning. He thinks he's gonna use more of the shortest screws than the longest screws. So do you agree with that reasoning? Yeah. So just work on those 3 questions right now. When you're finished, I would like you just to go into Study Island, and there's a line plots practice in Study Island. So line plots practice in Study Island. It's probably 10 questions. Do the practice. You could do the lesson if you wanted to, but do the practice, 10 questions. And if you don't, your goal is to try to get 70 or better. If you don't get 70, you can take it again. All right, so I will post the answers as well. And that's it. And hopefully I'm going to see you tomorrow on our Zoom meeting. All right, bye-bye.